Today we are presenting our simulation project. Our project consists of testing a wheelbarrow under various simulation conditions. The following video will explain a bit of the history of the wheelbarrow, the simulation studied, and its results.
Hello, I am Miguel Dominguez. I am a junior at Florida International University as a mechanical engineer with a focus in robotics. In my spare time, I model and sculpt 3D meshes.
I'm Clement Asbury, a junior at Florida International University studying mechanical engineering. I want to work with combat airplanes as soon as I graduate, and I enjoy to travel and spend time with family and friends.
My name is Roberto Lopez Ibanez. I'm currently a senior for mechanical engineering. In my spare time, I like to cook, do rocketry, and work with AIAA.
A brief history of the wheelbarrow. It was thought to be created by a man named Zhuzhou Liang in 231 AD. He was the prime minister of the Shuhan dynasty in China. Liang originally named the wheelbarrow the wooden ox, and it was used to carry soldiers and supplies to and from war. There's evidence showing that the wheelbarrows were actually being used before the time of Zhuzhou Liang in 118 AD, where people found paintings of men using wheelbarrows in the tombs of Sichuan, China. In Europe, the wheelbarrows were firstly used between 1170 and 1250 AD. This slide shows a variation of the wheelbarrow very similar to the ones that were used in ancient China. Our assembly consists of 2 steel feet, 2 handlebars, 1 wheel, 1 steel rod collector to hold the handlebars, a front steel connection, and a bucket. This is the exploded view of the assembly. Wheelbarrow, we did 2 types of simulation study. We did a load analysis and a flow simulation. For the load simulation, we did a 3,000 Newton force over the area of the bucket. This emulated that of having the weight of soil put on top of the wheelbarrow. We chose this load because we took the average density of the soil, which is 1.33 grams per centimeter cubed, in conjunction with the volume of the bucket, in turn giving us 3,000 newtons. And it used a solid mesh. For the flow simulation, we applied an airflow of 0.5 meters per second, including an initial mesh of level 5.
As shown in these images, it is seen that the factor of safety is 3.2, which is significantly higher than 2, so the wheelbarrow will not fail, meaning that the wheelbarrow is far from yielding. For the stress von Mises analysis, the minimum resultant stress was 0.0116943 newtons over meter squared, and the maximum stress was 5.82697 with an exponent of 7 newtons over meter squared. As you can see in this image, most of the stress was created at the bottom of the barrel, where most of the weight would be applied. If it were to have a high force, the factor of safety would surely decrease and the bucket would break at this point. For the strain, the minimum equivalent strain was 5.33618 with an exponent of negative 12, and the maximum was 0.0015651. In the picture shown, the strain occurred at the highest point where the barrel sits on the handles. Finally, for the stress test, we also created an optimization test to see what can be changed in the simulation to be at a better quality. The table shown shows that despite change in force or weight, the wheelbarrow still maintains a good stress ratio and, in turn, factors of safety. For the flow simulation, we studied at 0.5 meters per second. The flow shows that there are many points of turbulence and points where the pressure will build up higher velocities of the flow seen in the figure. Even though there is much more resistance at the front of the barrel, the flow becomes very laminar at the top and bottom of the barrel, meaning at those points the wheelbarrow is very aerodynamic. In conclusion, the wheelbarrow passes the static test and is able to carry more than we originally planned. The flow test shows that we have some turbulence, but not too many pressure points as to render the wheelbarrow unstable under higher winds. What we would recommend to change is the material to lower the cost of the wheelbarrow, and also to change the barrel to carry heavier loads over a larger surface area.